Welcome back to navydoc. Today we step aboard the most expensive war machine on the planet. It is not just a ship, it is a floating city carrying the power of total annihilation. But does it have the strength to confront a rising power surging from the east? Join navydoc as we find the answer right now. 80 years ago, the Pacific was the bloody arena of history's largest carrier duels. From the flames of Pearl Harbor to the fateful Battle of Midway, this ocean swallowed tens of thousands of sailors and hundreds of vessels. The wrecks of the USS Yorktown and IJN Akagi still lie silent at depths exceeding 16,000 feet, mute witnesses reminding us no empire lasts forever. Today, the seas are churning once more, but the enemy is no longer Imperial Japan. There are no kamikaze pilots with white headbands diving desperately into smokestacks. No combined fleet, fueled by the Bushido Code, ready to die for the Emperor's honor. The adversary this time is China. This is the chess match of the century between two superpowers. While Beijing launches new fleets, the pace of Beijing shipbuilding is staggering the West. With a production rate often described as dropping dumplings into a pot, Chinese shipyards operate 24/7. In just 4 years, the total displacement of warships they launched equaled the entire French Navy, a historic maritime power. This is a defense industrial explosion unseen since World War II. The United States has played its ultimate strategic card, a floating fortress reshaping the global order, the Gerald R. Ford-class supercarrier. Named after the 38th president, Gerald R. Ford. Few know that before entering the White House, a young Ford was a resilient assistant navigator aboard the light carrier USS Monterey. He tasted the brutality of Typhoon Cobra in 1944 firsthand, where men fought both nature and enemy fire to keep the ship afloat. This ship is the embodiment of American military doctrine, using superior technological quality to crush the adversary's overwhelming quantity. It is a steel-cold assertion that the United States is still here, and the ocean throne has not changed hands. Born from the CVN-21 program, it doesn't just replace the legendary Nimitz class. The Nimitz, the backbone of the U.S. Navy since the 1970s, served faithfully from the Cold War to the Persian Gulf and Afghanistan. But they are designs of an analog age. The Nimitz hull has run out of upgrade margin. Its electrical grid is overloaded by modern avionics, and its center of gravity cannot be optimized further. The Ford is a quantum leap in naval power, officially achieving full operational capability and global deployment readiness. With a price tag exceeding $13.3 billion for the ship alone, this is the single most expensive military asset in history, a massive investment for a singular purpose: maintaining the absolute dominance of the United States on the high seas. Let's look at the numbers. To visualize it, its 100,000-ton displacement is equivalent to crushing over 400 Statues of Liberty into a single block. The hull is forged from HSLA 115 super-strength alloy steel, lighter yet tougher than the steel used in the Nimitz, lowering the center of gravity and increasing survivability. The flight deck spans 256 feet, exceeding the area of 3 standard football fields. This is the world's most expensive real estate. Every inch on the deck is calculated. On the Ford class, the island superstructure has been pushed aft and reduced in footprint. This liberates valuable forward deck space, allowing aircraft to taxi, rearm, and refuel using a Formula One style pit stop model rather than the congestion often seen on the Nimitz. It stands as a floating tower 250 feet above the waterline, equivalent to a 25-story skyscraper drifting in the ocean, designed to withstand hurricane-force seas while maintaining enough stability for safe flight operations. This colossus serves a modern floating airport. The USS Ford operates a carrier air wing of over 90 aircraft. This is the true fist of the vessel. The ship itself is just the shell. The power lies in the wings it carries. The air wing aboard the Ford possesses more firepower than the air forces of 70% of the world's nations combined. With the capacity to carry JDAM smart bombs, long-range cruise missiles, and tactical nuclear weapons, it can level targets thousands of miles away in a single sortie. The core is the stealth F-35C Lightning II and the Super Hornet Rhino. This is the classic high-low mix. If the E-2D Advanced Hawkeye is the quarterback calling plays from the rear, the F-35C is the invisible assassin, or forward battlefield architect. With superior stealth, it penetrates deep into denied zones, not just to drop bombs, but to redraw the battlefield map for the entire fleet. Conversely, the FA-18EF Super Hornet Block 3 plays the role of the workhorse. After the F-35C clears the path and jams radar, the Super Hornet arrives as the bomb truck to rain fire on the enemy. This combination creates a comprehensive offensive and defensive formation. The support fleet has also undergone a metamorphosis. The aging C-2 Greyhound, with its noisy turboprops and cramped cargo hold, has ceded its role to the versatile CMV-22B Osprey. The Greyhound needed a runway to land. The Osprey does not. This tilt-rotor hybrid can land vertically, ferrying heavy F-35 engines weighing tons from shore directly to the ship in the middle of the ocean. This ensures the logistics supply chain is never broken, regardless of distance or sea state. Flanking the wing are the electronic warfare Growlers and the all-seeing Hawkeyes. In modern warfare, whoever controls the electromagnetic spectrum wins. The EA-18G Growler acts as the fleet's sorcerer, blinding enemy radar and rendering air defense networks useless. Meanwhile, the E-2D Advanced Hawkeye, with its massive rotating rotodome, serves as the airborne battle management command post, detecting cruise missiles from hundreds of miles out. But the future lies in automation. The U.S. Navy is integrating the MQ-25 Stingray aerial refueling drone and developing sixth-generation fighters paired with A1 wingmen. The MQ-25 is the most critical strategic piece of this puzzle. It operates as a flying gas station, extending the combat radius of the carrier air wing to nearly 1,000 nautical miles. This allows U.S. carriers to launch strikes from well outside the range of China's carrier-killer ballistic missiles, solving the difficult anti-access area denial equation. Powering this floating city requires a virtually infinite energy source. Two A1B nuclear reactors are the beating heart of this beast. Designed by Bechtel, the A1B is more compact, featuring 50% fewer valves and pipes than the Nimitz-class's A4W, significantly reducing maintenance man-hours. Yet, they generate 25% more thermal power output. This surplus energy is not wasted. It is reserved for the directed energy laser weapons the Navy plans to field in the near future. In the era of hypersonic missiles and suicide drone swarms, conventional kinetic CIWS rounds like the Phalanx will become too costly and too slow. Only directed energy weapons, firing at the speed of light for about $1 a shot, can effectively intercept hundreds of incoming targets simultaneously. The USS Ford has been hardwired to accept this future technology, transforming it into an impregnable fortress. Ensuring the ship operates relentlessly until 2060, without refueling its nuclear core once during its entire 50-year service life. Say goodbye to 20th century steam. The bulky steam catapult systems, prone to leaking, guzzling fresh water, and requiring hundreds of maintainers, are history. That was technology for the industrial steam age. The Ford utilizes the Electromagnetic Aircraft Launch System. It uses electricity to generate magnetic fields, hurling fighters down the deck like a railgun projectile. Its operating principle is similar to high-speed maglev trains or modern roller coasters. A massive electrical pulse surges along a 300-foot track, accelerating a 30-ton aircraft from 0 to 135 knots in barely 3 seconds. Smoother, gentler. Gone are the brutal jolts that fatigue airframes and cause spinal stress for pilots, common with steam systems. Most importantly, it increases the sortie rate by 25%, allowing the ship to launch more strikes in less time. In modern warfare, SGR, Sortie Generation Rate, is the metric of survival. Whoever puts more jets in the air during the first hour wins. EMALS helps the Ford achieve a density of firepower the Nimitz could never dream of, up to 160 standard sorties per day, capable of surging to 270 sorties during emergency operations for 4 continuous days. That is the firepower of an entire medium-sized nation's Air Force. Taking off is one thing. Landing is a deadly art form. The advanced arresting gear replaces traditional hydraulics with digital electromagnetic braking. The AAG system uses electric motors and water turbines to absorb the kinetic energy of the landing aircraft. Computer software controls the braking force, automatically adjusting cable tension the millisecond the tailhook engages. It allows for the precise recovery of every asset type, from lightweight UAVs to heavy F-35Cs laden with unexpended ordnance, without snapping cables or damaging the airframe. The old Nimitz system could not catch light drones or overweight aircraft. The AAG solves this physics problem, paving the way for the era of unmanned combat. Finally, there is the firepower. 11 advanced weapons elevators operated by magnetic fields. This was the critical choke point of legacy carriers. Ordnance sits deep in the ship's magazines, and moving it to the flight deck via cables took far too much time. Instead of the greasy cable and pulley systems of the last century, the weapon elevators on the USS Ford utilized linear synchronous motors. Imagine giant electromagnets pushing 10-ton ordnance lockers through the ship's belly at 150 feet per minute, 50% faster than the Nimitz class. No cables, no hydraulics, just the power of magnetic fields delivering lethal payloads to the deck in an instant. In high-intensity combat, this speed is the line between life and death. When the enemy is inbound, having your jets wait 30 minutes for bomb loads is unacceptable. On the USS Ford, the concept of waiting has been deleted. This is how Americans are redefining modern naval warfare. Complexity comes with risk. The engineering teams fought for thousands of hours to tame this elevator system. There were times when the ship's plumbing system clogged repeatedly, costing the Navy millions in repairs. But today, those glitches are history. The systems have reached full combat readiness, ensuring a continuous flow of munitions worthy of the Ford-class supercarrier's status. Regarding reconnaissance capabilities, inheriting ambitions from the Zumwalt project, the USS Ford is equipped with Raytheon's dual-band radar. This is a fusion of the X-band AN Spy-3 multifunction radar and the S-band AN Spy-4 volume search radar, creating a dome of observation with 0 blind spots, detecting sea-skimming cruise missiles or stealth aircraft in all weather conditions. It can track thousands of targets simultaneously, classifying which are enemy jets, which are missiles, and which are just a flock of migratory birds, then automatically distributing data to Sea Sparrow defense missiles for interception. However, economic efficiency is vital. To optimize budgets, subsequent ships like the USS John F. Kennedy will switch to the Enterprise Air Surveillance Radar. While the DBR is powerful, it is prohibitively expensive and complex to maintain. The EASR is cheaper, lighter, and shares technology with amphibious assault ships and destroyers, streamlining the logistics chain. This decision saves hundreds of millions of dollars per hull. Aiming for the long-term goal, building a 381-ship fleet anchored by 12 nuclear supercarriers. This is the U.S. Navy's ambitious navigation plan to restore the fleet size to Cold War levels, countering China's unprecedented expansion across every maritime front. But ship count isn't everything. The real adversary is Beijing's anti-access area denial strategy. A2AD is the term that keeps U.S. admirals awake at night. China does not intend to duel the U.S. in the open ocean. They want to turn their near seas into a death zone using thousands of land-based missiles. China aims to push the U.S. Navy out of the first island chain. They want to turn the South China Sea and East China Sea into a private lake where any U.S. warship entering is within range of thousands of missiles from the mainland. From zero in 2012, the Chinese Navy has transformed. In 2012, they only had their first carrier refurbished from an old Ukrainian hull. Just 10 years later, they have become the world's largest navy by hull count. Their boldest answer? the Type 003 Fujian aircraft carrier. Launched in 2022 and currently operational, the Fujian is a great leap forward. Unlike the previous two carriers, Liaoning and Shandong, which were based on Soviet designs with ski jump ramps that severely limited takeoff weight and fuel burn, the Fujian features a completely flat deck. China's mastery of EMALS technology was a major shock to the Western intelligence community. It allows the Fujian to launch heavy airborne early warning aircraft, leveling the technological playing field with the US. The Fujian runs on steam turbines fired by heavy fuel oil. This means it must always travel with a tail of massive replenishment oilers. If the US severs this fuel supply, or strikes the slow and vulnerable oilers, the Fujian Dragon will be stranded in the middle of the ocean, becoming a useless floating airport. Meanwhile, the USS Ford can circle the globe for 20 years without ever visiting a gas station. The real threat lies in coordination. When the Fujian deploys the KJ-600 early warning aircraft, their vision will extend hundreds of nautical miles. The KJ-600 looks identical to the US E-2 Hawkeye, using WJ-6C six-blade turboprop engines. Previously, Chinese carrier groups were considered myopic when operating far from shore due to a lack of airborne radar. With the KJ-600, they now have eyes in the sky, capable of designating targets for long-range missiles, directly challenging US air dominance. Beijing views the aircraft carrier as part of a combat ecosystem. Combined with carrier killers, the DF-21D and DF-26 ballistic missiles, these are the greatest threats. The DF-21D and DF-26 are nicknamed the Guam Express, with ranges reaching the US base in Guam. They are the world's first anti-ship ballistic missiles. Their operating principle is terrifying: launching into the atmosphere, separating the warhead, then plunging down onto the target at Mach 10. At that speed, interception becomes an extreme calculus problem, like using a pistol bullet to hit another bullet in flight. They create a death zone in the Western Pacific. This denial zone is designed to force US carriers to stand off at great distance, reducing the effectiveness of airstrikes. But remember this: technology can be copied, but military doctrine must be paid for in blood and time. This is the unassailable advantage of the United States. Let's look at operational reality. A Chinese J-15 or J-35 might have good aerodynamics and strong radar, but the pilot inside is the issue. US naval aviators are trained through the grueling Top Gun program, flying thousands of hours over water, performing hundreds of night landings. They inherit a legacy of experience from bloody dogfights in the Pacific, Korea, Vietnam, and the Gulf. From World War II to the Gulf War, the US Navy has operated carriers in combat environments for 80 years. They know how to extinguish a massive fire on a flight deck full of ordnance and fuel in minutes. They know how to maneuver a carrier strike group when hit by a Category 3 typhoon in the middle of the ocean. They know how to coordinate between submarines, destroyers, and anti-submarine aircraft to create a multi-layered defense shield. These procedures are not in textbooks. They are written in the blood of previous generations of sailors. That is institutional knowledge that China cannot steal via cyber espionage. The coordination between man and machine has reached an art form. China can build ships fast, but they have never tasted the pressure of modern naval combat. Their fleet has never been tested by fire. They have never had to order a missile launch while sirens scream and the ship shudders from a hit. In war, friction and the fog of war will expose every weakness of a fledgling force. This race is not just about steel. It is a confrontation between two world order models. One is an order based on international rules, freedom of navigation, and open alliances. The other is an order based on hard power, spheres of exclusive influence, and territorial revisionism. The outcome of this race will decide whether the Pacific in the 21st century will be an open sea for all, or the exclusive backyard of a superpower. Will the rise of the Eastern Dragon be enough to break Poseidon's trident? History has proven, he who possesses the strongest fleet writes the global rules. But technology is changing that. Will aircraft carriers become iron coffins in the face of hypersonic missile attacks? Or will they evolve to continue their reign? The ocean will be the final witness. And you? Do you bet on American combat experience, the masters of the ocean for nearly a century? Or on China's youthful vigor, the challenger changing every day? Leave your thoughts in the comments below. We really want to hear your perspective on this historic confrontation. Don't forget to like, share, and subscribe to navydoc so you don't miss our next deep dive military analysis. Goodbye, and see you next time.